Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have the second geometry lesson. The lesson is Unit 3, Lesson 2. The lesson is called Similarity of the Triangle. Last time we studied the similarity of polygons, but now and at the rest of the unit, I'm going to study the similarity of the triangle. Let's start the lesson. This lesson is divided, or similarity of triangle divided into three cases. In this lesson, inshallah, we are going to study the first case only, and the second and the third cases, inshallah, we are going to study in the next lesson. Okay, let we have the first case called AA. Okay, let we have two triangles like this, ABC and XYZ. Okay, if we have angle B equal to angle Z and angle C equal to angle X. Here we have in the first triangle two angles, and in the second triangle two angles. The two angles in the first and in the second are equal, or the two angles equal to their corresponding. In that case, since the sum of the triangle is 180, so angle A equal to angle Y. So in that case, the two triangles are similar. Again, if two angles in a triangle equal to two angles in another triangle, then the two triangles are similar, and this case called AA, because we speak here about two angles in the triangle. Okay, if two angles of one triangle are congruent to their corresponding angles of another triangle, then the two triangles are similar. Okay, now a special case from this case, if we have right angle triangle, okay, and an acute angle in the first triangle equal to acute angle in the second triangle, then the two triangles are similar. Okay, and this is a special case. Two right angle triangle are similar if the measure of an acute angle in one of them is equal to the measure of acute angle in the other triangle. Okay, now another special case. Let we have triangle ABC like this, and I draw a straight line intersect the two sides AB and AC at X and Y. Here we have, if the two triangles are if the two lines XY and BC are parallel, so we get that angle Y and B are equal, and angle X and angle C are equal. Here this is called corresponding angles, or F letter. Okay, in that case, here we conclude two triangles AYX and ABC, they are similar because here we have two angles, and here we have also two angles, and they are equal in measure. Another case, if we have a triangle like this, and I draw a straight line parallel to the base like this. Okay, if I connect BA outside and CA outside the triangle, then I get another triangle. This triangle here also, don't forget that XY is parallel to BC. Okay, this triangle AYX and ABC are similar. Why? Because angle X and angle B form Z letter. They are called alternate angles. And the angle Y and the angle C are also Z letter. They called alternate angles. Then the two triangles in that case are similar. So the corollary said, if a line is drawn to parallel one side of a triangle and intersect the other two sides, then the line containing them then the resulting triangle is similar to the original triangle. Here XY intersect AB and AC. Okay, so AYX, we get that AYX and ABC are similar. And here XY parallel to BC intersect BA but in outside and CA in outside. So we get two similar triangle. Okay. Let's solve the first example with us. Find the value of the symbol used. Number 1. Here we have in this triangle ED and BC are parallel. As I said in the previous remark, that angle E equal to angle C and angle D equal to angle B. So the two triangles ADE and ABC are similar. So I say that since ED straight line parallel to BC line segment, therefore triangle ADE similar to triangle ABC. Therefore, here AD, AB, DE, BC, AE, AC, and then I'm going to substitute AD equals AD and AB unknown, so I will not write this ratio. DE equal 12, BC 15, AE 4, AC equal excuse me, AEX AC x plus 9. Okay, from these two ratios I can find and make cross multiplication to find the x. So 12 times x plus 9 equal x times 15. So 12 x plus 12 times 9 times 9 equals 108 equals 15 times x equal 15 x. Okay, so I'm going to send 12x there as minus to be 15x minus 12x equals 3x, and this is equals 108 degrees. Send 3 there as a divided, so x equal 108 divided 108, not 180. Divided by 3, so x equal 36 degrees. Okay, now let's study another special case. If we have a right angled triangle, okay, and I draw a perpendicular from the right angle to the hypotenuse like this, BD perpendicular to AC. In that case, BD is called the altitude or the height of the triangle. Okay, Now, by looking carefully to this, what happened? Here we have three triangles, two smaller triangles, ABD and BCD, and the main triangle or the original triangle ABC. Okay, this is three triangles. Okay, by looking to this one, angle ABD and the angle CBD, the two angles here are complementary. I will call them X and star. So X and star, the sum of them equal 90. Again, X and star, the sum of them equal 90. Okay, by looking to the smaller triangle ABD, this is right and this is a star. So the sum of this angle and this angle equal 90. So this angle equal X, because X and star equal 90. By looking to this triangle, triangle DBC, this angle equal 90 or angle D equal 90, and this angle is X, so this angle is star. Okay, here we have triangle ABD contains star X and right. Again, star X and right. And this triangle contains star X and right. So the two smaller triangles are similar, and also they are similar to the larger triangle. Say again, triangle ABD, by looking to the order of the side, ABD, X star right, equal or similar to the other triangle, but I'm going to make the same sequence, X star right, BCD, and also similar to the larger triangle. Also, I will use the same sequence, X star right, ACB. So ABD similar to BCD, similar to ACD. So the rule is, in the right angle triangle, the altitude to the triangle which are similar to each other and to the original triangle. Okay, now remember with me the Euclidean theorems, the rules of the Euclidean theorem, because it is satisfied here in this triangle. Okay, remember with me. Number one, AB power of 2. AB power of 2. The side comes from the right angle. It is equal AD times AC. Again, AB power of 2 equal AD times AC. Like this. Okay. And BC power of 2 equal CD times CA. BC power of 2 equal CD times CA. And BD power of 2. BD equal DA times DC. Equal DA times DC. Okay. And BD equal AB times BC over AC, or the height equal side times side over the hypotenuse. Again, height equal side times side over hypotenuse. So it will be like this, BD equal AB times BC over AC. Don't forget, height equal side times side over hypotenuse. This is the Pythagorean theorem, Euclidean theorem, as we studied in the second prep. Let's solve example about this one. This is number 2, the rest of example of the previous example. Here the required is find the X and Y. Okay, this is the right angle triangle at A, and AD is the height or the altitude. So I can use the Pythagorean theorem, Euclidean theorem. So the proof is, since angle A is right and AD is perpendicular to BC, Therefore, y power of 2 equal BD times BC equals BD times BC equals 9 times BC equals 9 plus 16 equals 25. This is equals 9 times 25 equal to 125. So y equal square root 225 equals 15 centimeters. Okay, now to find x. X equal or x or AC power of 2 equal AC power of 2 equal CD times CB. Again, CD times CB, which is equals 16 times 25 equals 400. So x equals square root 400, which is equal 20 centimeters. Okay, now let's remember some about the circle as we studied in the third prep. Inshallah, we are going to use this points of circle, so I'm going to remind you the points that we need from the third prep. Okay, now remember with me, if we have a circle like this, and in this circle, this is AB is called diameter, and ACB is called inscribed angle. The inscribed angle, its vertex belong to the circle. Okay, remember with me the measure of the inscribed angle. The inscribed angle equal half the subtended arc, and here angle C, subtended arc AB, so angle C equal half measure of arc AB, and AB here equals 180, so angle C is right. The rule say that the inscribed angle in semicircle or subtended diameter is a right angle. This is the rule. Okay, and here we have some inscribed angles. If we have inscribed angle C subtend AB, and the inscribed angle D subtend AB, and the inscribed angle E subtend also AB, all of them subtended by the same arc, so all of them are equal in measure. Okay, so in the same circle, the measure of all inscribed angles subtended by the same arc are equal in measure. Next, remember with me the cyclic quadrilateral as we studied in the first prep and the third prep. Okay, here we have a circle like this, and this ABCD quadrilateral inscribed in the circle, so it is called cyclic quadrilateral. We studied some properties of the cyclic quadrilateral. The first property, I'm going to remind you, the opposite angles. The opposite angles in the cyclic quadrilateral are supplementary. So angle A and the angle C, their sum is 180. Also B plus D, their sum is 180. So like this is a cyclic quadrilateral. If we have in the cyclic quadrilateral each two opposite angles are supplementary or their sum is 180, so if angle D equals 110, so angle B equal 110 minus 180 minus 110 equals 70 degrees. Remember, the opposite angles in the cyclic quadrilateral are supplementary. Now if we have cyclic quadrilateral and this is side extended outside the quadrilateral, now we have here opposite angles, their sum is 180. If I need to find this angle, which called the vertex angle, it's called exterior angle. The exterior angle supplement the next to it, the adjacent to it, so it is equal 180 minus 80 equals 100 degrees. So by looking carefully, the exterior angle equals the opposite interior angle. Again, the exterior angle equals the opposite interior angle. Okay, the measure of the exterior angle at a vertex of a cyclic quadrilateral is equal to the measure of the interior angle at the vertex, the opposite vertex. Okay, now remember with me the angle of tangency. This angle ABC, formed from a tangent and a chord. Again, tangent and a chord. So this angle is called angle of tangency. Okay, this angle of tangency equal half the subtended arc. Angle B equal half arc BC. So if arc BC equal 100, so angle B equal 50 degrees. And also it is equal to the inscribed angle subtended by the same arc, like this. This is an angle of tangency. Okay, if the arc equal 100 degrees, so angle B also equal half 100 equal 50, and the angle B, which is the tangency angle, equal the measure of the inscribed angle that subtended by the same arc, like this. So angle B equal to angle D. This is tangency angle, this is inscribed angle. The measure of the angle of tangency is the measure of the inscribed angle subtended by the same arc. Okay, now the next question. Here example 2. In each of the following figures, prove that triangle ABC is similar to ADE, then find the value of x. It's very easy. Okay, now we have ED and BC are parallel, so angle D equal to angle B, angle E equal to angle C. Okay, since ED parallel to BC, therefore triangle ADE similar to triangle ABC, therefore AD AB DE BC AE Okay, and AE and AC are unknown, so I will not write them here. Complete the next by make cross multiplication. So 4 times x plus 5 equal 6 times 4x minus 5. 6 times 4 equal 24. X 6 times negative 5 equals negative 30. Equal 4 times x equal 4x. 4 times 5 equal positive 20. Okay, here I'm going to send 4x to the left side and negative 30 to the right side. So 24x minus 4x equal 20 plus 30. 24 minus 4 equals 20. X here 20 plus 30 equals 50. Send 20 there divided, so x equal 50 divided by 20 equals to 0.5, and this is the value of x. Okay, the next example. Here example 3. In each of the following figures, find the value of x. This is also Euclidean theorem. So since angle B is right and BD perpendicular to AC, therefore x equal, or x power of 2 equals dA times DC. So x power of 2 equals 18 times 8 equals 144. So x equals root 144 equals 12 centimeters. Number 2. Here also right angle triangle and EC perpendicular to BD. I will write the same as I wrote before, since since angle C is right and since EC perpendicular to BD, so EC power of 2 equal EB times ED. Again, EC power of 2 equal EB times ED. So 6 power of 2 equals 4 times 2x plus 1. So 36 equals 4 times 2x equal 8x. 4 times 1 equal positive 4. So I'm going to send 4 as minus. So 8x equal 36 minus 4 equals 32. And then I'm going 8 with divide. So 32 divided by 8 equal 4. So x equal 32 divided by 8 equals 4. The next example. Okay, here in example 4, in the opposite figure, DA parallel to CB, prove that triangle AHD similar to triangle BHC. Okay, here since the two lines are parallel, so angle C equal to angle D alternate and angle B equal to angle A alternate. So since DA parallel to CB, therefore measure of angle D equal to measure of angle C, comma, measure of angle A equal to measure of angle B, and this is called alternate angles. Okay, and therefore AH, BH, HD, HC, AD, BC. The second required is prove that AH times HC equal DH times HB. Okay, by looking carefully to the proportion, here AH and HC are opposite to each other, and HD times HB opposite to each other. So by using this step, by make cross multiplication, therefore AH times HC equal HD or DH times BH or HB. This is the second required. Next question. Now, in this example, ABC is a triangle, DE parallel to BC, AX intersect DE and BC at X and Y. State three pairs of similar triangle. It's very easy. Here angle D equal to angle B, angle X equal to angle Y, angle E equal to angle C, angle AXC equal to angle AYC. Okay, now we have ADX and ABY similar, AEX and ACY similar, ABC and ADE are similar. Okay, so since ED parallel to BC, therefore triangle ADX similar to triangle ABY and triangle AXE similar to triangle AYC and triangle ABC ADE similar to triangle ABC. Okay, now we have three pairs of similar triangles. Okay, now I need to conclude this equations. Dx over dy, okay, equal xe from over yc equal de over bc. Okay, to prove this one, I'm going to search the triangles included each pair. Dx dy, dx by included in the first similarity. xeyc in the second similarity. debc in the third similarity. So I need the three similarities. Okay, so I will start therefore from the first similarity. ADX ABY. Here AD AB DX BY AX AY. Therefore, from the second similarity, AX AY XE YC AE AC. And from the third similarity, therefore AD AB DE BC AE BC AE BC excuse me AE AC. Okay, now we have 9 ratios, 3 equal, 3 equal, and 3 equal. Okay, by looking carefully to the first and the second groups, here, by looking carefully, here a x over a y, and also here a x and a y. Okay, and in the second group, here in the second and the third, xe, ae over ac and ae over oc. This is the first, I'm call it 1, the first relation, the second relation, and third relation. Okay, by looking carefully here, this is a common ratio between the first and the second, and there is a common ratio between the third and the fourth. So the 3 ratios are equal. I'm going to take what? From the 3 ratios, I'm going to take dx over by from the first ratio and xe over yc from the second ratio and de over bc from the third ratio. Therefore, from 1, 2, and 3, therefore dx over b y equal xe over yc equals de over bc. Now this is question without figure. Okay, so we are going to draw this by ourselves. AB and DC are 2 chords in the circle where AB intersects CD at E outside the circle. Okay, the first step, we have a circle. Okay, now I'm going to draw 2 chords, AB and CD, but AB and CD intersect at E outside the circle, so they will be like this. Here we have AB, A, B, and this is C, and this is D. They intersect outside the circle at E. Okay, where E lie outside the circle, AB equals 4, DC equals 7, BE equals 6. Prove that ADE, so I need to connect AD, similar to CBE, so I need to connect CB like this. Okay, ADE and CBE, the 2 triangles, I need to prove that they are similar. Remember with me what we took, that the inscribed angles subtended by the same arc are equal. So angle A is equal to angle C. Okay, because they subtended arc DB, and angle E is a common angle here. ADE, CBE is a common angle. Okay, now we have angle A and angle E from the first triangle equal to angle C and the angle E in the second triangle, so the 2 triangles are similar. I will say that since angle A, comma, angle E, angle C subtended by arc BD, Therefore, measure of angle A equal to measure of angle C. Okay, in triangle ADE and triangle CBE, since measure of angle A equal to measure of angle C and angle E is common, therefore it's called the common angle. Therefore, triangle ADE similar to triangle CBE. Therefore, proportion AD CB DE BE AE CE. Therefore, okay, here I'm going to call ED X. Again, ED, I'm going to call it X. So, AD over CB, AD over C. I will not write this ratio because both of them are non-exist. DE equal X. Here, BE 6. AE equals 4 plus 6 equal 10. CE equals X plus 7. So, I am going to make a cross multiplication. X times X plus 7 equal 10 times 6. X times X equal X power of 2. X times 7 positive 7X equals 10 times 6 equals 60. I'm going to send, because we have second degree equation, so I'm going to send 60 to the left side. So X power of 2 plus 7X equal minus 60 equal 0. Now I'm going to make a factorize, or by using the calculator, mode equation 3. So X equal 5 or X equals negative 12, but X is a length, so negative 12 is refused. So X equal 5, so CE, therefore CE equals 5 plus 7 equals 12 centimeters. The next question. ABC and DEF are two similar triangles. So I have to draw two triangles like this. I will call them ABC, A, B, C, and the other DEF. Okay, so now AX perpendicular to BC, so I'm going to draw a perpendicular from A to BX, and DY perpendicular to EF, I'm going to draw from D perpendicular to EF like this. Here angle, this is called X, AX, and this is DY. Angle X is right, angle Y also is right. Okay, don't forget, the two triangles are similar, ABC and DEF. So angle B equal to its corresponding, which is E, and angle C equal to its corresponding, which is F, and the angle A equal to angle D. Okay, now prove this one. bx times ey equals cx times eye. By looking carefully to the two triangles, we have three pairs of similar triangles: ABC, DEF, similar; AXB and DYE, similar; ACX and DFY, also similar. So, by looking carefully to this line segments, I'm going to check they are included in which triangle, and I'm going to work on these triangles. Okay, BX here, YF here, CX here, and YE here. YE is here. So BX included in ABX, XC included in AXC, EY in DYE, YF in DYF. So I'm going to work on the small triangles. Okay, now I'm going to prove that the small triangles are similar. Since triangle ABC similar to triangle DEF, therefore measure of angle B equal to measure of angle E, comma, measure of angle C equal to measure of angle F. Okay, since AX perpendicular to BC, therefore measure of angle AXB equals 90. Therefore triangle AXB similar to triangle DYE. And from the similarity, AX DY XB YE AB DE. Also, since DY perpendicular to EF, therefore measure of angle DYF equals 90. Therefore triangle AXC similar to triangle DYF. Therefore AX XB AX over EY, excuse me, AX DY, AX DY, XC YF, AC over AC over DF. Okay, by looking to the two proportional, here we have AX over DY is common. I'm going to choose yellow. AX and DY is a common. So XB over YE equal XC over YF. Therefore from 1 and 2 therefore XB over YE equal XC over YF, and by making cross multiplication, therefore cross multiplication XB times YF equal XC times YE. XC times YE, and this is the required he asked about. And this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.